Hwk18 question 3 then gives us this expression here and asks us to find dy dx. Now hopefully you remember that before you can differentiate anything, you have to have all the terms in this format, ax to the n. So what we need to do first of all is go about simplifying this. So y is going to be, if we multiply the top out, x times 3x gives us 3x squared. Then I've got minus 25x and minus 9x from the middle, so that's minus 34x. And minus 3 times minus 25 gives me plus 75 on the end, and then the whole lot is divided by x. Now what I'm going to do is divide each term by x. So 3x squared over x gives me 3x, 34 over x, 34, and on the end I get 75 over x. Now I need to get this into the correct form so I can differentiate. So y is going to be 3x minus 34 plus 75x to the minus 1, and now every term is in this format here, so I can now find what dy dx is. So differentiate minus 34, I get nothing, and differentiate 75x to the minus 1, I get minus 75x to the minus 2, which again, if you want to, you can write as 3 minus 75 over x squared. Part B asks us to find the coordinates of the turning point, so we know that at the turning point dy dx equals 0, so 3 minus 75 over x squared is equal to 0. So 3 is equal to 75 over x squared. 3x squared, then if I multiply through by x squared, is equal to 75. And x squared of 3, which is 25. So x is going to be 5. And again, the question tells us that x is bigger than 0, so we don't need to worry about the negative part. And then it says find the coordinates, we need to find y. So we can say that when x equals 5, y is going to be, into the original equation, 5 minus 3, and then 3 times 5 minus 25, all divided by x, which is 5. And if you work this out, y comes out to be minus 4. So the coordinates of the turning point are 5 minus 4. Part C asks us to determine whether this turning point is a maximum or a minimum, so what we need to do is differentiate a second time. So d2y dx squared, well dy dx is all the way up off the top. If you differentiate 3 here, you get 0, and if you differentiate 75 minus 75x to the minus 2, you get 150x to the minus 3. Which if you prefer, you can write as 150 over x cubed. Now, when x equals 5 at the turning point, d2y dx squared is going to equal 150 divided by 5 cubed, that's 125. This comes out to be 1.2. 1.2 is positive, so positive. Therefore, we have a minimum point. And finally for part D, we told that the point P on the curve has the coordinate x equals 2.5, and the question asks us to find the equation of the normal going through this point. So first thing we need to do is find the y value at this point. So y is going to be the first bracket is x minus 3. Is x minus 3? So 2.5 minus 3 gives us minus 1/2. The second bracket then gives us 3 lots of 2.5 minus 25. This is minus 17.5. and everything is divided by 2.5, and if you put that in your calculator, the answer comes out to be 3.5. And then dy dx at the same point is equal to 3 minus 75 over 2.5 squared. So 3 minus 75 over 2.5 squared comes out to be minus 9. So the gradient of the normal is going to be 1/9. So using y minus y1 equals mx minus of y minus 3.5, I'm going to write that as a fraction, y minus 7 over 2 equals 1/9 of x minus x1. x1 is 2.5, so again I'm going to put that as a fraction, 5 over 2. If you multiply through by 9, we get 9y minus 63 over 2 equals x minus 5 over 2. Multiply through by 2, so 18y minus 63 is 2x minus 5. Put everything onto one side and make it equal to 0. So 18y minus 2x minus 63 and bring the minus 5 over to make a plus 5 gives us a minus 58. That's all equals 0. 2 will go into all of these. So 9y minus x minus 29 is equal to 0, and that's the equation of the normal at the point P.